Hi everybody, it's Professor Mitchell. We're finishing up Chapter 3 today on numeration systems and whole number operations. Today we'll be looking at division of whole numbers. So we'll talk about the meaning of division through various models, the inverse relationship between multiplication and division, the special cases of division by 0 and 1, division algorithms including the standard algorithm, division in number bases other than 10, and mental division skills and estimation techniques. So the same topics that we've talked about for addition, subtraction, and multiplication. So 3 models for division that we'll talk about. First is the set or partition model, where the set of elements representing the dividend is partitioned into B subsets, where B is the divisor. We also have the missing factor model, which says that A divided by B is a unique number C, provided that B times C is equal to A. And of course, all of these things will make more sense when we look at examples. And then there's the repeated subtraction model, where the divisor is continually subtracted from the dividend until only the remainder is left. As an example of the set or partition model, suppose we have 18 cookies and want to give an equal number of cookies to each of 3 friends, Bob, Dean, and Charlie. How many should each person receive? So here's the model for that. Basically, just take your set containing 18 cookies and divide them into 3 subsets. Notice that each subset has an equal number of cookies. That equal number is the quotient or the answer to the division problem. Each person gets 6 cookies. In the missing factor model, we would put it like this. If each friend receives C cookies, then the 3 friends total will receive 3C, which is 18 cookies. Therefore, 3C is equal to 18. So you're just looking for a missing number C, such that 3 times C equals 18. Since 3 times 6 equals 18, we've answered the division computation by using multiplication. So the definition of division of whole numbers: for any whole numbers A and B with B not equal to 0, we'll come back to that in a little bit, A divided by B is equal to C if and only if C is the unique whole number such that B times C is equal to A. Now in this case, that unique whole number is kind of important. We're going to come back to that when we talk about 0 divided by 0. The number A is called the dividend, the number B is the divisor, and the number C is the quotient. Remember that A divided by B can also be written as A over B, or B divided into A. Pay special attention to this way of writing it. Notice that the order gets switched around. That's something that sometimes throws people off. The division algorithm explained. Suppose we have 18 cookies and want to package them in cookie boxes that hold 6 cookies each. How many boxes are needed? If 1 box is filled, then there are 18 minus 6 equals 12 cookies left. If 1 more box is filled, then there are 12 minus 6, which is 6 cookies left. And the last 6 cookies will fill another box. You see that we used a total of 3 boxes, which means that 18 divided by 6 is equal to 3. So the division algorithm, and technically this is not an algorithm. An algorithm usually means a method for doing something. So the division algorithm is strictly not an algorithm, all right? What it says will make a lot more sense when we look at an example. I'm going to try to rephrase this in English. Given any whole numbers A and B, with B not equal to 0, there exist unique whole numbers Q, which is the quotient, and R, which is the remainder, such that 2 things are true. Number 1, A is equal to BQ plus R. And number 2, R has to be at least 0 and less than B. So for example, when you divide a number by 8, the remainder has to be a number 0 through 7. That's what that's saying. When A is divided by B and the remainder is 0, we say that A is divisible by B, or that B is a divisor of A, or that B divides A. And we're going to be talking about this case more in chapter 4. All right, if 123 is divided by a number and the remainder is 13, what are the possible divisors? This is a great problem. I just love this problem. If 123 is divided by B, then from the division algorithm, 123 is equal to B times Q plus 13, and B is greater than 13. Remember that the remainder is less than the divisor. So another way of saying that is B is greater than 13. So if we take this equation, 123 equals BQ plus 13, and we subtract 13 from both sides of the equation, or you can say by definition of subtraction, BQ has to equal 110. So what we know at this point is that BQ has to equal 110, and B has to be greater than 13. So what we're going to look at now, we're looking for two numbers whose product is 110, where one number is greater than 13. So there are only a limited number of possibilities for that. If we list all of the numbers that multiply to 110, we come up with these 4 pairs. We see that 110, 55, and 22 are the only possible values for B because each is greater than 13. So the answer to the original problem is that the divisor could be 22, 55, or 110. Let's talk about division by 0 and 1. If n is any non-zero whole number, then n divided by 0 is undefined. You've heard this before. 0 divided by n is 0. And 0 divided by 0 is undefined. And I thought it would be worth, hopefully somebody's done this before, but I thought it would be worth talking about why does each of those things make sense. So if you try to build a story problem around n divided by 0, let's say 18 divided by 0, and we take that cookie problem from earlier, suppose we have 18 cookies and want to put them in boxes that hold 0 cookies each. Imagine a really, really small box. Right? How many boxes are needed? Well, that problem doesn't make sense, right? I mean, no matter how many boxes you have, you'll never be able to put a cookie in any of the boxes. Okay, so that's why we say that's undefined. On the other hand, suppose we have 0 cookies, like I have right now. Kind of wish I had some. Suppose we have 0 cookies and want to put them in boxes that hold 18 cookies each. How many boxes are needed? Well, 0 boxes, because I don't have any cookies, so I don't need any boxes. Now, the 0 divided by 0 is a little more difficult to understand using this, sort of partition model. So I thought I would turn to a missing factor model for that. 0 divided by 0 is supposed to answer the question 0 times what equals 0? Well, you could put any number there, right? 0 times 2 is 0, 0 times 5 is 0, 0 times 17 is 0. And if you remember earlier, in the definition of whole number division, it said that this quotient was supposed to be unique. So we have to say that that's undefined. All right, I always like to point out this relationship, relating multiplication and division as inverse operations. Starting with addition and subtraction, Of course, they're inverse operations. When you turn addition into repeated addition, you get multiplication. And when you turn subtraction into repeated subtraction, you get division. Multiplication and division are also inverse operations. All right, this is something we looked at in the last section. This is called the quotient rule for exponents. If a, m, and n are natural numbers with m greater than n, then a to the m divided by a to the n is equal to a to the power m minus n. To divide powers, you subtract exponents. All right, let's look at some division algorithms. Using base 10 blocks to develop the standard division algorithm. Looking at the problems 726 divided by 6. So here I have the number 726 represented with base 10 blocks. I have 7 flats, 2 longs, and 6 units. And I want to divide that by 6. So the first thing I'm going to do is notice that I have a set of 6 flats. All right, so I can group those together. And that's going to leave me with 1 flat, 2 longs, and 6 units, which represents 126. So now I want to try to continue dividing this into 6. So what I'm going to do next is take this flat and trade it in for 10 longs. And now I can divide those 12 longs into 2 groups of 6 longs each. And it just so happens that my 6 units make 1 group of 6 units. So I have, so here's basically what happened when we did that. First we grouped our 1 group of 6 flats, which represents 100 sixes. That left us with 126. Remember, we had that left over, okay? And then if we subtract 60, that represents a group of 10 sixes. Subtract 60 again, that's another group of 10 sixes. And then 6 is 1 group of 6. Altogether, we have 121 groups of 6. Using the standard division algorithm, 6 into 7 goes 1 time. So let me just, I'm going to take my pen here and write this the way you're used to. So normally you would put a 1 here. That 1 right there represents 100 sixes. And then 1 times 6 is 6, because we're writing the 6 in this place. It represents 600. I do that subtraction, I get 126. 6 goes into 12 2 times. Notice we are in the tens place, so that represents 20 sixes. 2 times 6 is 12. Put a 0 on there to remind me it represents 120. And then 126 minus 120 is 6. 6 goes into 6 1 time. 1 times 6 is 6. 6 minus 6 is 0. Okay. So this is basically what we just did. And this is just another way of writing it. You don't have to pay too much attention to this. All right, base 5. So division, you know, just when you think that you've got it down with addition, subtraction, and multiplication and other bases, along comes division. And that's kind of like, you know, you may have some memory of elementary school where, you know, you kind of got through addition, subtraction, multiplication without too much trouble, and then along came division, right? Division in different bases can be performed using the multiplication facts and the definition of division. And just like in base 10, computing multi-digit divisions efficiently in different bases requires practice. So here is our base 5 multiplication table, just like we were using in the last section. All right, so here is a sort of repeated subtraction model for division in base 5, and then we're going to look at the standard algorithm, and I'm going to actually switch over to my tablet to hopefully, you know, help that make a little more sense. I just thought of one thing. Okay, it occurred to me that it might be useful to have the base 5 multiplication table within view when we're doing this, but well, I'm going to be switching over to my tablet in a second, so it's not going to help all that much. Anyway, I did write it on the tablet screen, so we'll have it there. Okay, so we'll do this using repeated subtraction. That's a little easier. So if I multiply 43 times 10, I get 430. So we so far have one group of 10. 3241 minus 430 in base 5 gives you 2311. At any point, if you need another minute to think about any of this, go ahead and pause the video and try to convince yourself. When I do the standard algorithm on the tablet, it also might become a little more clear then. If we subtract another group of 10, which is 430, 2311 minus 430 is 1311. And we can take out one more group of, I should be saying 10, not 10. 1311 minus 430 is 401. So I'm done taking out groups of 10. Now I'm going to take out a group of 2. 2 times 43 in base 5 comes out to 141. 401 minus 141 is 210. If I take out another group of 2, 210 minus 141 leaves me 14. And now we're done because 14 is less than 43 in base 5. So how many 4 3s altogether did we take out? We took out 10, 10, 10. So it's like nickel, nickel, nickel. And then 2 pennies, 2 pennies. That adds up to 3 nickels and 4 pennies. So the quotient is 3 4, and the remainder is 1 4. So now I'm going to switch over to the tablet. Hopefully this will make a little bit more sense when you kind of see and hear me working it out. From the repeated subtraction earlier, we know that 4 3 goes into 3 2 4 3 times. Now normally what I would do next is I would just do 3 times 4 3 and write the answer here. But since base 5 multiplication is still really new to us, I'm going to do that over here, right underneath my base 5 multiplication table. All right, so the first thing I'm going to do is 3 times 3. And I see that in base 5, 3 times 3 is 1 4. So I'm going to put a 4 here, carry a 1. 3 times 4 is, let's see, 2 2. 2 2 plus 1 is 2 3. So we know that 3 times 4 3 is 2 3 4. So now we'll do the subtraction. 4 minus 4 is 0. I can't take 3 from 2, so I have to cash in one of these for a set of these. And now remember, base 5, think of this as nickels and pennies. 1 nickel and 2 pennies minus 3 pennies leaves you with 4 pennies. Okay. So now I'm going to bring down the 1. And again, we know from the repeated subtraction earlier that 4-3 goes into 4-0-1 4 times. So now over here, I'm going to do 4-3 times 4. 3 times 4 in base 5 is equal to 2-2. 4 times 4 is 3-1. 3-1 plus 2 is 3-3. So 4 times 4, 3 is 3-3-2. We'll do this subtraction. I can't take 2 from 1, and I can't even borrow 1 from here, so I'm going to start by taking one of these and cashing it in for 5 of these. That's really how I should read that number. I should read it as 5. Okay? And now I can take one of these. Remember, this is a nickel. So if you take one of those, it leaves 4. See, when you're not doing this in base 10, it's where you really, really have to think. If I take 2 pennies from a nickel, I'm left with 3 pennies. And if I take 3 from 4, I'm left with 1. Oops, I just remembered. See? It even throws me. I already had 1 here, so I shouldn't have turned that into a 10. I should have turned it into 1-1. This is 1-1, which means this is a 4. Okay. All right. So the quotient is 3-4, and the remainder is 1-4. So now let's go back to the PowerPoint. Okay, whoops, spoiler. How did I get on this slide? Oh, that's a different PowerPoint. Pay any attention to that? Yeah, this is where we are. Yep, I grabbed something from that other PowerPoint that I wanted to show you later. All right, so here is your standard algorithm. It looks just like what we did, except they didn't quite show as much work as we did, you know, doing all the different pieces. So it's going to take practice, and I'm not going to assign a ton of these, don't worry. All right. If anything, I might assign you a few more that just have single-digit divisors. I think those will be easier than these multi-digit ones. I won't give you too many of these. All right, mental math tricks for division. First, there's breaking up the dividend. So, for example, to divide 5,648 by 8, we're in luck because 56 and 48 happen to both be divisible by 8. 5,600 divided by 8 is 700. 48 divided by 8 is 6, which means the quotient must be 700 plus 6, which is 706. Using compatible numbers. So if you're dividing 105 by 3, if you realize that 90 is a nice number to divide 3 by, you can break the 105 into 90 plus 15. 90 divided by 3 is 30. 15 divided by 3 is 5. So this quotient is 35. Another example of using compatible numbers, 232 divided by 8. 240 is very easy to divide by 8, and it's 8 more than 232. So if you rewrite 232 as 240 minus 8, 240 divided by 8 is 30. 8 divided by 8 is 1. This quotient is 30 minus 1, which is 29. And then some estimation tricks, again with compatible numbers. You can just round your dividend off to a number that's easy to divide by, in this case, 6. Instead of using 3,752, I'll use 3,600. 3,600 divided by 6 is 600. And then finally, a little review of order of operations. When no parentheses are present, and I guess no exponents are present, then all we have to worry about is multiplication, division, subtraction, and addition. So remember, please excuse my dear Aunt Sally, parentheses, exponents, and then multiplication, division, followed by addition, subtraction. And what a lot of people don't realize is that the multiplications and divisions are performed in the order they occur. So multiplication is not necessarily done before division. And it's the same thing with addition and subtraction. And lately, whenever I talk about this, I think of these some of these problems that go viral on social media. So here's one I found a while back. It says viral math problem. This is taken right off social media. 6 divided by 2 times 1 plus 2. And people would get into these vicious fights about what the answer is. Right? And I got dragged into it a few times, I'm sorry to say. The correct way to do this is like this. You start with 6 divided by 2 times 1 plus 2. Notice we do have parentheses here. So I'm going to do the problem in the parentheses first. 1 plus 2 is 3. Now the 2 parentheses 3 means multiplication, right? So what a lot of people are tempted to do at this point is do 2 times 3 is 6, and then 6 divided by 6 is 1. That's not how it works. Multiplication and division are done from left to right in the order they occur. So believe it or not, the next step is to write 6 divided by 2 is 3, and then 3 times 3 is 9. So if this problem or a similar problem goes viral on social media again, and you feel like getting into the nasty comment war that always comes with problems like this, you'll know that you know how to do it, all right? And that is going to take care of section 3.5 and chapter 3. So next time, we'll start chapter 4.